Hello and welcome back to another Mr. Talbot Maths video, and in this week's video I'm going to be talking through proportion. So without further ado, let's get stuck into a few of these problems here, and I'll go through exactly how to do them, and I'm going to give us a couple of methods to do them as well. So you might think that actually I prefer this one or I prefer the other one, which is absolutely fine. Okay, so it takes 30 minutes to travel 15 miles to work. It's about how long it takes me, to be honest. How long would it take to travel 45 miles? Okay, now, intentionally, this is the most straightforward of the three questions I'm going to be going through today. But I want to explain how this works because obviously the other two are based on this method as well. So, we need to think about this problem in terms of if I increase one thing, would it affect the other, and how would it affect the other? Now, if I increased the miles or the distance to work, would that increase the time it takes me to get there? Now, logically speaking, it would. The longer distance you have to travel, the longer it's going to take. Now, what I'm going to do is I'm going to give these some letters. So 30 minutes on minutes, that's time. I'm going to give that a letter of T, and then miles, that's D for distance. So I'm going to put this into a table, make it into a table. Time is 30, and then the distance is 15. Now, I want to get from 15 miles to 45 miles. So, like we just said, as I increase one, the other should increase as well. And so, if I times 15 by 3, I get 45. Now, it should increase at similar rates. And I don't mean by adding 30. Proportion doesn't work like that. You've got to multiply or divide by the same amount to keep things in the same proportion, the same scale. So I need to also times by 3 on the top here. 30 times by 3 is 90, so it should take 90 minutes to drive 45 miles. Okay, now that's the first method to do this, and if you notice here, to get from the bottom row, or the distance, to the amount of time it would take, you times by 2. Now, that is important because actually that's the scale factor, that's the proportion that they're in. One is double the other. Now I'm going to show you some notation here, which should be, well, it might be familiar, but it will be probably incorporated into exam questions that you might see, and they might ask for equations, so you might have to do this. You might not be able to just use this table. So you might see something like y is proportional, and that's what that symbol means, to x. Now, in the case of this question, we've got t and d, so we've got that t is proportional to the distance. Time is proportional to the distance. Okay. Now that gives us that time is equal to the distance times some number. I'm going to call this number k for the moment. That k stands for the constant of proportionality, and it's very often written that letter as a k. You could put it as anything though, technically. Now I've got this equation. I'm going to plug my numbers in, so my original numbers, so 30. That's the time, so 30 is equal to k, which is what I'm going to try and work out, times by the distance, 15 miles. Okay, now if I divide both sides by 15, what I'm going to find is that the constant of proportionality, the k, is going to be equal to 2. Now if I plug that back into my original equation, we get that the time is 2 times the distance, or you could write that as 2d, because usually with algebra you don't write the multiplication symbol in between a number and a letter. Now, we want to know how long it would take to travel 45 miles, so we're just going to substitute that in to d here. So t is equal to 2 times 45, which is equal to 90 minutes. Okay, which is exactly what we got up here using this table. But like I said earlier, the question, typically exam questions, they ask you to work out or to form an equation, to give an equation relating two variables. If 10 people can do a piece of work in 15 days, in how many days will 6 people complete it? Okay, now this question is slightly different because if we were to increase the number of people, they would be able to do the same piece of work in fewer days. And so if we increase one, the other is going to decrease. Right, so that isn't the same. It's not then going to be direct proportion. This is going to be what's called inverse proportion. As one increases, the other decreases. Okay, now what I'm going to do is I'm going to put this in a table again. So I'm going to abbreviate that to P for people, and then I'm going to put that again as T for time. So P, T, 10 people, and we've got 15 days it would take them to do this piece of work. Right, now I need to get from 10 people to 6 people. I can't really go from 10 straight to 6, so I want to go from 10 to 1, and then from 1 to 6 people. Right, now we've said if I increase 1, the other decreases, or the alternative of that is if I decrease 1, so divide by 10, I increase the other one, and this is called inverse proportion, because we end up doing the inverse operation. So instead of dividing, the inverse operation is multiplying. So times by 10, that's 150. Now the next bit I need to times by 6. So I need to divide 150 by 6. And that should give me 25. So for 6 people, it would take 25 days. Okay, now I'm going to show you the other method, and again, this is with an equation or a formula that we're going to make and then substitute some numbers in. Right, now, what we want to do here is, because it's inverse proportion, P is going to be proportional to the inverse of T, so 1 over T. Okay? Now, again, we're going to convert that into an equation. And we do it exactly the same way. P is equal to some constant, K, times by 1 over T. And we can rewrite that as K over T. Okay? So P is equal to K times 1 over T, or P is equal to K over T. Either of those will be sufficient. Now, for the next bit, we need to plug our numbers in. So we're going to plug in 10 for P. So 10 is equal to K over, now the time T was 15. We're now going to multiply both sides here by 15 so that we can work out K. And we get that K is equal to 150. That's an important point because we're going to get marks for that if we were doing an exam question, but also we can now plug that back into our original equation. So P here is equal to K, which is 150 over T. Okay, so that is equation, or formula if you like, because we've got some letters in there that we need to substitute in for. Now, what we're going to do is we're going to substitute in P is 6. So, P is 6 is equal to 150 over T. Now, the next bit we need to do is now times by T on both sides. And then we're going to divide by 6. So we've got 6T is equal to 150. And not essentially, but what ends up happening here, which you will notice if you do a lot of these questions, is if you need to work out the denominator, you end up essentially swapping the denominator with this number, the other side of the equals, and yeah, you can, once you've done it quite a few times, you'll be able to just notice that trick and do it immediately without having to write this out every single time. So divide by 6 now on both sides. Get T is equal to 150 divided by 6, which again is 25 days. Thank you for watching my videos. If you enjoy them, make sure to drop a like, subscribe and hit the bell notification because it really helps me out. Of course, you can always support the channel by scanning the QR code here and buying me a coffee. And you can also watch one of these other videos over here if they interest you. Hopefully this one is the one you're after, the one just here. That's the one, that's where I was supposed to put it. Anyway, have a look at that one. That's a great one. See you in the next one. Bye-bye.